Let's talk about Kaplan-Meier plot. So the reason why we want to talk about Kaplan-Meier plot, like if you remember, we talked about when the study opens, you have so many people, some of them experience the event, some of them never do, right? But you don't see them again, they're censored, okay? But if you're starting the study, you have maybe 100 people at the beginning and you're following them for 10 years, that means that some of them will experience the event, some of them may never do, but at the beginning of your study, you have 100. Later, you might not have 100 again. And we need a way to visualize that, to see what's happening in the study. That's what the Kaplan-Meier plot tries to do. So if you look at the resident doctor study that we looked at, this is exactly what this plot looks like. So if you assume that we have 100 resident doctors in the beginning, right? And this is the time zero when they start, okay? And at this point in time, you start following them up and you're asking to see whether they've experienced the outcome. Every year you go back and ask them, did you experience have they experienced the outcome? Have they exited specialty practice? Have they stopped practicing clinical medicine? And you ask them, and then you go back again every year, you ask them, right? But sometimes some people, you don't find them. Maybe the phone number that they have, maybe it's lost, or they don't want to be reached for whatever reason. If for those people you don't find, every time you start looking for a person, you don't find them, you don't know if they've experienced the outcome, you draw this line. So if it's going like this, you draw a line at that point in time when you stop finding them. That's this guy. Okay, that short vertical line tells you that that person, one person, or at least one person is censored at that time point. Okay, it tells you that at least one person is censored. I need to clean this to show something else. All right, so we know that at least one person is censored at this time point. But there's something else that's going on in the Kaplan-Meier plot, is that as you're going, then the plot, you have a step down. That step down tells you that at least one person has experienced the outcome. Okay? Every time you have a Kaplan-Meier plot and you have a vertical dash in the middle, it tells you that at that time point, one person has been censored. When you have a step down, it means that at least one person, at least one person has been censored. When you have a step down, it means that at least one person has experienced the outcome. So you do that and you follow all through the study. Some people are censored, some people experience the outcome. At the same time point, you might have censoring, and some people might be censored, some people might be experiencing the outcome. Like in this case, at the same time point, there's some censoring going on. There's also the outcome being experienced at the same time point, and you keep following them and you keep following them. And this line does not get to 0. So this is a probability. It goes from 1 to 0. Because the line doesn't get to 0, you can see that we stop at 0.6 in the graph, but in fact, the line gets to somewhere around 0.9. It tells us that only about 10% of the people experience, or no, maybe not 10, maybe because this is not 0.9, this is 0.85. Only about 15% of the people ever experience the outcome. The rest of the group are censored administratively. At the end of your study, maybe this is 10 years, you can find them. They have not experienced the outcome. They are continuing to practice clinical medicine, right? Then this is what your plot looks like. This is a Kaplan-Meier plot. Question? So look, where you have a question.
Yes, thank you very much. Can you hear me?
I can hear you, okay.
So I just wanted you to take the previous explanation again, the one where you talked about. Okay. Okay, I think Dr. Ebo has answered it, but about this one, so at that point where you talked about where censoring and people experiencing the outcome is happening,
yeah.
I think the representation is different, right? That's why it is a horizontal line.
That's why it's a horizontal line, correct? Okay. Yep. Yep. Okay. Yeah, that's why it's a horizontal line. Okay. Thank you. Yeah, so this is what the Kaplan-Meier plot looks like. The Kaplan-Meier plot is so important. If you look in the New England Journal of Medicine, for instance, you will see Kaplan-Meier plots everywhere. It's a very commonly used plot because, you know, it shows you what's happening in a study, in a longitudinal study over time. And the beauty of the Kaplan-Meier plot is that you can also use it to compare groups, right? First of all, you can include a confidence interval. So this is a confidence interval for the plots, the same plot that you just saw. This is what the confidence interval looks like. And you can see that as there's fewer people in the study, so here there's so many more people in the study, the confidence interval is narrow. But as you get to the end of the study where there's fewer people, some people have left the study because they've experienced the outcome. Once they experience the outcome, you're not following them up further. Or if they're censored because you can't find them, you're not continuing to follow them. So there's fewer people, and so the confidence interval becomes wider. So you can see this plot sort of starts very narrow and then it becomes wider. So this is what the confidence interval looks like. But we can also, you know, estimate the median survival time. The way that we usually summarize survival time is the time to the event, is using the median. And the reason why we cannot use the mean is because some people are here who we administratively censored, right? We don't know if they ever experienced the outcome. So we have a variable that's not going to be normally distributed. There's going to be a lot of skewing, right? So we will have to, and we also don't know. We really just don't know. So we will have to use a median to estimate the survival. Okay. So if you wanted,
there's a question.
Okay.
Someone's asking about the horizontal line, and I think there are two horizontal lines there.
This one.
This question came before this slide, so I think I want to ask on behalf of that person. Maybe this one, maybe that you go over the step, like demonstrate the stepwise horizontal line and how to read this graph
again. Okay.
One.
All right.
And then secondly, the horizontal line you have here, explain that. And then when we get to that horizontal line at the median, you can explain that as well so that people are really clear what the different lines mean.
Okay. All right. That's great. Thanks. So let me change to the pen. Yeah. So here, again, this is the Kaplan-Meier plot. It's a plot of the survival time, the time to the event. So you have 100 people and you start following them from the beginning of the study, and they either experience the event or they are censored. Those are two possibilities. They either experience the event or they are censored. So at every time point, every year you go back, you ask, you check, have they experienced the event or you censor them, right? So if they experience the event, so if you start from 1, if they experience the event, then you have a step down. A step down in the curve means that at least one person has experienced the event. If you have a small, tiny step down, it means that it's just a small proportion of the population has experienced the event, maybe 1 person, maybe 2, depending on how large. If you have a large step down, and you might see some Kaplan-Meier plots that go like that, and then like something like that, that means that a lot of people are experiencing the event at the same time point, right? So that's the first thing that I explained, the step down. The second thing is the dash that goes through the line. So you have a line that's going like that. There's a step down that shows someone experienced the event, but you also have this vertical dash here that shows that some people were, at least one person was censored at that time point. Okay, and that's the same thing. So you see here, someone was censored, here someone was censored, here even towards the tail end, someone was censored, here someone was censored. But we also have this censoring right here. it's not a vertical line. It's in the middle of a step down. This is what it looks like. Okay, this censoring that's in the middle of a step down is occurring because at the same time point, and this time point is maybe 36 weeks. So you went back at the end of the 3rd year, right? And some people are experiencing the event at that time point, but they are also being censored. Some other people are being censored. Maybe 4 people are being censored. 2 people are experiencing the event. So you want to depict both at in the same plot. That's how you do it. So you're not going to do this by hand, by the way. The software is going to do this for you. Okay, but this is how you would interpret it. I also had one line that went from here, right? The line that went like that. And that line, sorry, forgive my drawing skills, I'm terrible at drawing. Good thing I didn't go to fine art. So you have a line that goes like this all the way through the last person. So you have the last person that was in your study, and you draw that line, and then that line goes all to the vertical line on the y-axis. That line here just tells us what proportion of the population is left in the study. So at the end of your study, you have a line that goes to 0.85. It tells us that 85% of the population were still remaining in the study when you stopped the study. That's all it says. Not a big deal. But we also had a line on the second plot that went through the middle, somewhere like that, that went through the middle. And I said that that line is the median, but that's not through this middle. Sorry, this is wrong. So this line, let me go to the exact one. So here, okay. So that line that goes to 0.5, okay, this line that goes to 0.5 on the y-axis is the median survival time. We don't calculate, we don't find that on this plot because nobody gets to 0.5, okay? In this case, this is another plot. This is a plot for cancer patients that goes to 0.5 is the median survival time. And that tells us that at this time point where the 0.5 line crosses through the Kaplan-Meier plot. So if you go down here, so if someone asks you what's the median time to remission for cancer patients in your study, you will say that it is, maybe this is 23, okay? Because yeah, you'll say that the median time to remission in your study was 23 weeks. I glossed over it the first time, because I wanted to make the point I was trying to make was that the mean survival time cannot be calculated. But if you want to read off this line, the median survival time is 23 weeks. Okay. All right. So let's keep going. So the other thing that you can do here is that you can compare survival curves. So going back to the residency plot that we're looking at, in this case, in the first one, we had both males and females, right? Here, we had both everybody, one survival plot. But here we have separated male and female out. And we can see that the survival curve for females is higher than survival curves for males. Who wants to try to explain what's happening here? Who is experiencing the outcome more? Is it males or females? And why?
Can I try, sir?
Yeah, go ahead.
The males are experiencing it more because from the plot, when the event is being experienced, you noted that it's downward movement. And we can see that the line moves downward compared to that of female. That means males are experiencing it more.
Excellent. So males are experiencing the outcome more. So every time that the plot, and you can see that very early in follow-up, the males are beginning to, the survival plot for the males is going down. So males are leaving the clinical medicine more in this population. Okay. So that's one of the things that you can do. You can do this by visualizing it, but you can also use something called a log rank test. So a log rank test will give you a p-value, right? And the p-value can tell you whether there's a significant difference between the two curves, right? So if it looks at the entire length of the two curves and sees whether the curves are significantly different. If the curves are significantly different, then you will say, oh, okay, males are experiencing it more, is significantly different from females. But there's one thing to bear in mind, is that without the log rank tests, it's hard to just look at this plot and say males are experiencing more. And it's because of this. This is that same plot. If you include the confidence intervals, you will get something that looks like this. So this is what the confidence interval would look like. The greenish blue is for females, the reddish whatever is for males. And you can see that there is overlap. That overlap tells us that there is no clear demarcation in the survival curves, right? If you had repeated this many times, you still get sometimes the survival curves that will look like female for the males, right? So, and if you look at the p-value for the log rank test here, it will not be significant. So that's why you have to be careful when you're interpreting Kaplan-Meier plots that don't have confidence intervals. If it doesn't have the confidence interval presented, you should look for the log rank p-value in the plot. Okay, question? Any question?
Yes, so
okay.
You said we're going to use a p-value. That means we're going to apply null hypothesis here?
Yes.
So what is the null hypothesis in this case?
The null hypothesis is that the plots are not different.
Okay, all right, thank you.
Yeah. Okay. So that means that if the p-value is then significant, it means that at least one plot, one survival curve is different from the next. All right. So that is Kaplan-Meier. So basically what we did in the last several minutes is just explain what the Kaplan-Meier plot is. This is very, very important. You know, you come across it in landmark papers every time that there is a new drug trial. Almost all the time they present a Kaplan-Meier plot, especially if the outcome is death. You know, Kaplan-Meier plots are used very often, but not necessarily for the outcome of death. You know, every time there's a time to event data that's collected, Kaplan-Meier plot is presented, okay?